Friends, I'm Sharath. Now I'm going to show you how to analyze a continuous beam by stiffness matrix method. Here there is a simple example of a continuous beam. Here one fixed support and a roller support and a pin support, and the loads are 100 kilonewtons and 250 kilonewtons, which are placed concentrically for each beam. The span of each beam is 5 meters and 5 meters, and EI is constant. Now let's look at the procedure of how to analyze continuous beam by stiffness matrix method. Step 1, calculation of decay. Decay means degree of kinematic indeterminacy. What is degree of kinematic indeterminacy? Degree of kinematic indeterminacy is the number of moment causing forces. The degree of kinematic indeterminacy is the number of moment causing forces for support A. For support A, since it's a fixed support, the number of moment causing forces are 0 because it is restrained in 3 directions. So 0. For B, it is a roller support. For roller support, there will be 2 moment causing forces, but since there is no horizontal force, we are not considering horizontal force. So total forces will be 1. For C, it is a pin support. The pin support can move only one direction. So degree of kinematic indeterminacy for C is 1. So total degree of kinematic indeterminacy is equals to 0 plus 1 plus 1, which is equal to 2. So we will get a 2 by 2 matrix. Step 1 is completed. Step 1 is calculation of degree of kinematic indeterminacy. Step 2, calculation of fixed end moments. Fixed end moments. So in span AB, in span AB at MF AB, fixed end moment equals to minus WL by 8. W is load in the beam and L is the length of the beam. So W is minus 100 into length is 5 divided by 8, which is equals to minus 62.5 kilonewton meter. So MFBA is WL by 8. We will get 62.5 kilonewton meter, which is just opposite of MFAB. In span BC, fixed end moment at B is equal to minus WL by 8. The load in span BC is minus 250 into 5 divided by 8, which is equals to 156.25 kilonewton meter. Same as MFCB. MFCB is plus WL by 8, that is equals to 156.25 kilonewton meter. So we calculated fixed end moments in span A, span AB and span BC. And next, step 3. In step 3, we have to apply rotations at system supports or system coordinates. So apply rotations at system coordinates. It will be like this. B. So this is the first coordinate, this is the second coordinate, 5 meters, 5 meters. For this we have to eliminate or we have to neglect external forces since there is no sinkage of support, hence we are neglecting external forces. Step 4. Calculation of forces or moments due to applied rotations. So let let us call this P dash matrix. So it will be like this. P1 dash, P2 dash. Now P1 dash. P1 dash means MF BA plus MF PC. What is MF BA? 62.5 minus 156.25, which is equals to minus 93.75 kilonewton meter. P2 dash. P2 dash means MFCB. What is MFCB? 156.25 kilonewton. So we calculated force or moments due to applied rotations at system coordinates. Now step 5. In step 5 we have to calculate moments due to external loads. Calculation of forces or moments due to external loads. Here we are neglecting forces due to external forces. So what are the external forces? External forces means one is yielding of supports, and in this problem we are not considering yielding of supports. So P1 equals to 0, P2 equals to 0.